Hello again. This is going to be probably one that many of you will not enjoy. I personally love trig, but many people don't love trig. Don't know why, but yeah. So trig is, I don't know how much you know about trig. Basically, it's rules which apply to triangles. It's fancy manipulation of triangles. So we always talk about it in terms of theta, which is a particular angle. For basic trig, which is this stuff, we use a right angle triangle because it makes our life easier. What sine? Okay, so three trigonometric formulas are sine theta, which is opposite to theta, divided by the hypotenuse of theta, and this ratio is constant if the value of theta is constant. Cosine is adjacent over hypotenuse, and then the tangent is the opposite over adjacent. This is important because using these values, like let's say I know that the opposite value is 7 and the adjacent value is 4. I can now work out what theta is because I know that tan theta equals opposite over adjacent equals 7 over 4, which means theta equals tan to the negative 1, or inverse tan, you'll find that button on your calculator, 7 over 4. And then you can find what theta is. I'm not going to do that because I need a calculator for that. Oh, quick thing. Yeah, most of the time you want to use calculators for trig. I'm not a fan of calculators. I try to do most of my maths in my head because I find that's useful for a number of reasons, but when it comes to trig, you need a calculator. Or you need to memorize a ridiculous number of values. And then cosine is just adjacent divided by hypotenuse, and tangent is opposite over adjacent. I don't think you need anything more complicated in maths GCSE. Oh, and then there are these two triangles, which you really should know. There are some people in my A-level classes who don't know this, and it's worth knowing. So this triangle is for angles of 45 degrees, and then it's 1, 1, root 2. You can work this out by taking a unit square, which means that everything is a right angle. And a unit square means that every side length is length 1. Cutting it in half. Obviously, if you cut 90 in half, you get 45 and 45. And then using Pythagoras theorem, which is a squared plus b squared equals c squared. 1 squared plus 1 squared equals c squared. 1 plus 1 equals c squared. C squared equals 2. C equals root 2. I know that I've said before you can have plus or minus root 2, but you can't have a side length that's negative, so it has to be positive root 2. And this is useful because it means if I ask you for tan 45, you shouldn't need to use your calculator. You can just go 1 over 1 equals 1. Cos of 45, adjacent over hypotenuse, 1 over root 2. Does that make sense? 1 over root 2, by the way, can be rewritten as root 2 over 2, where you just multiply the top and bottom by root 2 over 2, by root 2 over root 2 even, which is the same as 1, which is why you can do this. And root 2 over 2, sometimes you're asked to do this if you're told to rationalize the denominator, meaning not having any surds, which is square roots or things like that in the denominator. And then there is this triangle, which is the 60-30 triangle. This is made by taking an equilateral triangle of side length 2, which means that each angle has 60 degrees, cutting it in half down the middle. And so this becomes 30 because 90 plus 60 is 150. 180 minus 150 is 30, so this angle has to be 30. We know that this length is 1 because 2 divided by 2. And then 2 squared is 4, 1 squared is 1, 4 minus 1 is 3, square root of 3 for this length here. And then this is useful because if I asked you for cos of 60, you look at 60, adjacent over hypotenuse, 1 over 2. If I asked you for sine of 30, for example, opposite over hypotenuse, 1 over 2. Does that make sense? I hope that makes sense. Yeah, if it doesn't, just tell me or something. So this is your simple trig, and then you get a little bit more complicated trig, which could come up. For the purpose of this, we're taking this triangle, and this only applies, by the way, for right angle triangles. If you don't have a right angle triangle, you can't use this. You can use sine, cosine, and tan, but not using these formulas. Here, this works for any triangle though. So the sine rule is, so I've just labeled the sides as A, B, and C, and their opposite angles as capital A, capital B, capital C. Sine rule states that the side length divided by the angle divided by sine of the angle is the same as the side length divided by the sine of the angle, etc., etc. Or sine A, you can do it the other way around. So sine A, over A is the same as sine B over B, which is really useful because let's say you're told that this is 7, this is 5, and this is 30. You can calculate this value because you know that 5 over sine 30 equals 7 over sine A. So 5 sine A equals 7 sine 30. We also conveniently know what sine 30 is because sine 30, 1 over 2, so therefore we know that sine A equals 7 divided by 2 divided by 5, so 7 over 10. So therefore, A equals sine to negative 1 of 0.7. So you can use that. Then you've got the cosine rule. This one's a little bit more complicated. It says that a squared, this value, is b squared plus c squared minus 2 times b times c times cos of a. Or if you rearrange it to find a, then cos of a is b squared plus c squared minus a squared divided by 2 times b times c. These, I'm pretty sure you're given this formula in your equation booklet. Check that. Don't just trust me on that because it depends what exam board you're using. But you might be given this formula, but if not, it's very much worth knowing it. And then this is useful if you have if you have two lengths, and then either the third length or an angle, and you want to find the other one of those. And then finally, this area I don't think is maths GCSE, but it's so useful knowing this formula, I'm going to tell you anyway. The area of a triangle is always equal to half of side A times side B times sine of C. Basically meaning that if I take this triangle, if you know this value, and this angle, you know the area, which is obviously very helpful. It's just this formula. Yeah, I hope that's useful.